Just to give you a little bit of background, I'm not a forester. I have absolutely no idea about anything to do with forestry, so don't ask me anything about that or answer. As Gaetan mentioned, I'm working part-time with the Regional Service Commission and part-time with the Institute, trying to collaborate on certain efforts that are similar. So we have the same issues with planning at the RSC level. So since some of the approaches that we're taking are of interest to the Institute, and similarly, the opposite is also true. So we started working on this project. As it came up in the talks earlier, it's hard to really figure out what these climate changes really mean, right? So we have a bunch of ideas about degrees and some indicators, but really what does that mean for forestry? We need to look at things at a different scale, maybe at a geographic level, to get an idea of how things are changing. So in order to do this work, which was the synthesis of already available climate data at the ecoregion scale in the province, we used the Uranos climate data. So in 2016, the province commissioned a report from Uranos, which is a climate change consortium, based in Quebec, to project what New Brunswick will look like until 2080 or even a little bit beyond that. And so what they ended up with was these maps like this, which are more or less descriptive and may not be super useful for the planning of smaller scale things. But they also produced the actual rasters from which these maps were made. So I requested them at the Regional Service Commission to be able to do some more detailed analysis, and it was also useful to the NHRI, so we kept working with that. Charles Book, who was here earlier, also produced some climate data in 2015, and these are high definition rasters, 30-meter resolution. So it's really interesting, and he refined them in 2019 as well. So to give you an idea of what that looks like, they're GIS rasters that look like this. The Department of Energy and Resource Development also produced the ecoregion and eco-district shapefiles. So that's what we use as a basis for this analysis. Then in terms of tools, so everything that's been developed here was done with open source software. That's really important for me at the Regional Service Commission because we don't have a lot of resources, so we use open source GIS as well as R and R Studio to do the analysis. And we use the leaflet and plotly frameworks to make interactive HTML files out of these data. So really the whole purpose of this, which I haven't really gotten to yet, is to kind of take these data, which there's a lot of, and make them a little bit more useful for everyday practitioners. Not to say that the rasters aren't useful for scientific analysis. So here's the pipeline that we used. So we started with the Uranos data and the Book data, which were together about 1,500 rasters, and used the eco-district shapefiles. Then did spatial averages using these data to then produce a new geo-package which contains all of these different indicators. So what that resulted in is one file with something like 248 different climate attributes for each year and each of these different indicators. Then all of that data was gathered up, cleaned up, and put through Plotly and Leaflet to produce web applications. So I guess just to give you an idea of what this gives, I have a little demo here. Eventually, these data will just be able to, we can put them directly onto a website, and anyone who wants to use them will be able to use them. So it creates this neat page. You can choose English or French. So that's another part of this. Everything was done bilingual. And then using two different climate scenarios as well. So for those who may not be familiar, RCP 4.5 is the kind of more conservative, or optimistic scenario now, which is to limit global annual temperatures to only a 2-degree increase. And then RCP 8.5 is the business as usual scenario where we just continue living as we are doing usual.
The screen is not showing.
Oh, okay.
You're seeing the
Yeah,
first screen.
thank you.
It's probably because this is still open.
Okay.
Sorry, it seems like PowerPoint has crashed, so. Okay,
Received now?
yes.
Okay, so I'm going to have to navigate on the screen that I can't see. So again, English and French. So if we're in English here, we can see the RCP 4.5 and RCP 8.5 scenarios. And these are the different indicators that we're looking at. So, for example, in the first one we have freeze-thaw days, rain days, snow days, average annual temperature, days with temperature above 25 degrees, below zero, etc. And so for each one, we decided to show it into 2 different formats. So if we're looking at freeze-free days, for example, we can look at things as a chart. So it gives this interactive chart, and what you see here on the right-hand side is all the different eco-districts of the province. So let's say you're really interested in one in particular, and let's look at Grand Lake. So you can just double-click on it, and it gives you how things will be evolving over time, and you get the actual values here for each one of these eco-districts. Then you can also decide that you want to compare 2 different eco-districts, so you can activate more of them. Some of them are more similar than others. And compare them. So now it gives you the values over time of each of these eco-districts. So the eco-district level may not be the most useful at this point, but as I'm going to mention later, we can actually probably scale this down to eco-sites, which may be more useful from a management perspective. So this is one of the views. If we go back, we can also, I guess we're in French now, look at the map. So again, we end up with a, right now it's not connected to the internet, I think it's just, oh, it is connected to the internet. That's why it's loading the base map, but it works offline as well. So you have all the different eco-regions of the province here. You can click on one of them, it tells you what it is. It tells you what the current, or 1990 levels are of, in this case, freeze-thaw days. So the number of days, and then you can look at 2020, 2050, and 2080 to get an idea of how things will be changing. And then in that bubble, it also tells you what the difference is in terms of, in this case, number of days, and as a percentage. So that might be useful for practitioners to gauge really how things are changing over time in these different locations. And so we have that for all of the different indicators. Now I'm going to have to reopen PowerPoint. Bear with me. So what are the advantages of this approach? Well, it's reproducible to the ecosite scale. And this approach is simple and user-friendly for anyone who's using this on the field. In fact, we could probably even add a geolocalization tool so that if you're out on the field and you want to see what the conditions are for this ecosite eventually in the future, it would give you all the information that you wanted in the field. Simple visualization of overall trends, and it allows you to compare different locations just looking at the graph and seeing how the trends change on these different indicators. So that's a positive, and it could be used to inform different adaptation measures that were discussed earlier. So this is really a proof of concept. There's a lot of work to be done. There is a lot of assumptions and limitations in this tool. So first of all, the polygons that are considered, at least on this ecoregion scale, are quite large. So there's the real possibility of having very skewed data based on latitude and different positions on the landscape. So really having a smaller scale is actually going to give you a lot better resolution and a more useful value. The original Oranos dataset didn't actually take into consideration meteorological data across the border, so in the States, which led to a map like this of the different weather stations that were used. So that actually creates a kind of an edge effect on the western border and on the south border of New Brunswick. There's some climate stations in the PEI in Nova Scotia that were used, but mostly they're all in Quebec and New Brunswick. So that actually causes an issue here. So I didn't show the data that came from Charles, but his soil water content data, it's really great. It's at 30-meter resolution, but he also included water bodies. And I didn't realize that at the time when I was doing this analysis, but I will redo it to exclude those water bodies. And at the ecosite level, it'll actually be a lot more useful again, because the resolution is 30 meters, and since I'm taking spatial averages, it could be misleading. And then these data are modeled, so these are all based on models, they're all projections. Reality will probably be something between these two models, assuming that governments do mobilize to try to achieve this 2 degrees of warming. But the thing is that this is all reproducible, so a script has been written. As long as the data comes in the same format, we can just redo this over and over again as data come in. Also, these data are mostly annual and at seasonal scales, so that's something we need to keep in mind. A lot of the issues surrounding forestry are probably going to be due to kind of extreme weather events that we can't consider using these different models. So prolonged droughts or freezing rain, etc. So that's something that needs to be considered apart. If you just look at these data, you'll see that really the future is extremely peachy for the forestry industry. There's going to be tons of sufficient water, and there's going to be really warm temperatures. But that's I think we're missing a piece of things there. Okay, apparently it's not showing very well, but yeah. So the upcoming products, which are supposed to be listed here. So NHRI has a bunch of other products that are coming along. We're working on adaptation plans. So there's a vulnerability assessment report, which should be coming out within the next few months, as well as an adaptation guide. The vulnerability report was done in collaboration with Dr. Yves Claveau, and the adaptation guide is again with Dr. Yves Claveau and Jean-Martin Lucier. And then, so these are actually really just the documentary that you saw is also part of that. So it's the first step to kind of get the word out, get people talking about climate change and starting to look for solutions. So these tools are all going to be adding into to that work and to give us better tools to deal with the issues. So this work was done as a partnership between many different organizations. So I just wanted to thank our partners, and I'll be taking any questions. I know it was pretty quick, and it's really just an overview of a proof of concept. So